Welcome to the 18th lecture of Digital Electronic Circuits. In this lecture, we will deal with pulsed operation of digital circuits. So we will deal with the pulsed operation of some basic gates and OR and NOT, and one example of NAND and NOR will be dealt with. So before going into pulsed operation, what is meant by pulse or pulse time? Pulse means it is basically a timing signal. It is basically a timing signal whose value varies between 0, logic 0 and logic 1 at certain time instance. So here we need to analyze the output of the gate, at this time instance. So coming into a pulsed operation. So first one is pulsed operation of AND gate. So I am having AND gate A, B. Output X is equal to A dot B. So here I am having a pulse for A. This pulse A, and here I will give pulse of B. So I am dividing it into different time instance. So T1, T2, T3, T4. Let T1, T2, T3 and T4 be the time caps for switching. For A, I am drawing the waveform. So this is 0 and 1. Now coming to B also, I am drawing some waveform. So this is a B waveform. This is the logic 0 of B waveform. So how will be the output X? This is a question. How will be the output X? So I am going to draw the output sequence X. So before T1, before the time instance T1, A is 0 and B is 1, and operation is AND 0, 0 and 1. That is remaining it as 0. At time instant T1, 1.0, that is 0. Here, time instant T2, 1.1. 1.1 is 1. At time instant T3, 0.0, that is 0. Becomes 0. T4, 0.1, that is 0. And again, after T4, 1.0, that is remaining it as 0. So this is logic 0 and this is logic 1. So depending on the pulse input or pulse train input, you are getting the output. Hope you have understood the concept. So here you are having logic level 0 and logic level 1. Before time instant T1, B is 1 and A is 0. So 1.0 is 0. Here 0.1, 0. 1.1, 1, 0.0, 0, 1.1, 0, 0.1, 0 is going in. So that will be the sequence of X. Now coming into pulse operation of OR gate. So I am giving the example of two input AND gate I have given you. So here I will give with three input OR gate. So having A, B, C. So here what will be H is equal to A or B or C. That means if any one of the input is 5, the output is 5. So I am drawing pulse trains for A, B and C. Okay. So I will divide like this. Now divide it into 4 time instance up to 4 only. Okay. So this T1, T2, T3 time T4. Okay. So this is A, B, C. Now comes H. H is the output. Okay. Now I am drawing the pulse train of A. This is 0 at time 1, 0, 1. It is 0. This is 0 and 1. So it is here it is 0, 0, 1, 1, 0. This is logic 0 and this is logic 1. So this is 1. This is logic 0, 1, 0, 1, 0, 1. Okay. So that is so you have got 3 pulse trains of A, B and C. So first I will do it. So this is time instant T1, T2, T3 and T4. So before T1, what do you get? 1 or 0 or 0. What is it? 1. Sorry, it is 0 or 0 or 1. It is 1. At time instant T1, 1 or 0 or 0. What is it? 1. Here what do we get? 0 or 1 or 1. That is again 1. 1 or 1 or 0. That is remaining as 1. 1 or 0 or 1. That is remaining as 1. So it should be always 1 for this particular time instance. According to the pulse train which I have drawn. Okay. Hope you have understood the pulsed operation of AND gate and OR gate. Okay. So you can have you can have for any number of inputs. Okay. Now let me explain the pulsed operation of NOT gate. Pulsed operation of NOT gate. Okay. So for NOT gate you are having only one input. Okay. So A, the output is S is equal to A bar. Suppose the pulse train of A, 7 time instance. So let it show for so this is 0, then it has 1, 0, 1, 0, 1. So this is T1, T2, time instant 3, 3, T4 and T5. So what is H? It's equal to A bar. So here what happens? Here this is logic 0, 1. 0 becomes 1. 1 becomes 0. This is 1. That becomes 0. Time instant 3, it becomes 0. 1. This becomes 0. That means you will get the exact shifted sequence of A. So that is basically a NOT gate operation. Okay. So here what happens is that the entire signal gets complemented. Okay. So this H is a complement of A. H is a complement of A. So that is basically the pulsed operation of NOT gate. Now coming into NAND gate, pulsed operation of NAND gate and NOR gate. With NAND gate and NOR gate I will stop the presentation on that. Okay. Pulsed operation of NAND gate. So what is basically NAND? We'll get H A B. We'll get H is equal to A B the whole bar. So if I am having only two inputs, so I will draw the pulse train first to 4 time instance, then it will be easy for you. So here you will get A and B. Here you will get H. Okay, it is easy if you draw the truth table also. Inputs, output. Output is H equal to AB the whole bar. AB 0 0 0 1 1 0 and 1 1. 0 dot 0 0 the whole bar. 0 the whole bar is 1 1 1 0. Okay. So I will draw the pulse train. Okay, for the sum T1, T2, T3. So B also I am drawing the pulse train. Okay, so how will be X? 0 dot 0. It is 0, 0, 1, 0, 1, 0 dot 0. That is, you will get the output as 1. 1 dot 1, you will get the output as 0. 1 dot 0, you will get output as 1. 0 and 1. Then 0 dot 1, you will get the output as 1. Okay. So I think you have got the operation of pulsed NAND gate. Okay, you can go with the pulsed NOR gate also. That pulsed NOR gate I am not discussing it right now. That you can make it as an assignment, or you can see from your part. Okay. So with that, I think you have got the logic how to do the pulsed operation of AND or AND as well as NAND. So you can try by your own of pulsed XOR gate, pulsed XOR gate, etc. That you can bubbled gates also you can try of your own. Thank you, and we can meet in the next lecture based on Boolean algebra. So with this I am okay, and in the next lecture we will deal with inhibit circuits, and so by lecture number 19 we will be stopping with module 1 for the time being. Thank you.